So how do you actually design a database if you don't start with tables? Most people open a schema editor and then start creating tables. Users, my projects, my requests. I think that is backwards. These tables capture your first guess about your app, but not really how the app actually works. So before I show you the 7 tables that I've designed behind GrowthMap, which is my app one, let me show you where they come from. I didn't start with SQL, I started with responsibilities. So what does this system need to remember and store the state of? What belongs together, what changes over time, what gets reused. So once these boundaries are clearer, the tables almost become good designs for themselves. And only then did I end up saying, okay, Postgres is easier because this app is built around relationships, and as you know, Postgres is a relational database. And then starting to think about the individual entities, right? So relational database enforces these relationships. It's easier for me to query and inspect them without writing loads of code, and also making the debugging easier. So let's jump into how this database design actually looks like, and hopefully you can take away a thing or two to apply to your own app that you're building. For those of you joining me, I'm an ex-senior product manager and I'm learning to be an AI engineer in public. I've decided not to wipe code and think about system design and architecture because that matters a lot. I'm building 6 apps, starting simple with API with inference and working all the way up to autonomous apps. This is app 1 called as GrowthMap. All the code and resources are free, and the link below in description. Subscribe and build alongside me. So where we left off from the last video is the interaction flow which we designed. We did take a couple of core decisions that we are going to have a free journey and a paid journey, and we created the interaction for the free journey. Right? So as we step through this, and here's the video, I've linked this if you want to go look at how we arrived at that. As you start going through this flow, it becomes very evident that there are some responsibility buckets in terms of this flow, where there's a visitor and user and their identity. There is the concept of a prospect or a domain. There is a qualification attempt that is happening, and there is a set of executions where we call external APIs and get those responses. And there is some evidence of us passing this data, right? So the key bit that I started with is understanding that tables need to be built around responsibilities and not the other way around, right? So let's try to see how that looks like. So as we step through this, the visitor to the site is a user. And we need a users table to capture all of the individual users, and then we can start to think about whether they're a free user or they're a paid user eventually. So we need to store the state of users, and then comes monthly usage. So this is one common mistake which probably most people do, right? Would you actually put monthly usage in its own table? And for me, I would say no, only because a user's email doesn't need to change every month. A user is more or less, once a user is created, it's there. The usage, however, keeps changing. It is a time dependent data, and if you start adding this kind of like almost like a time-based tracked data which on your users, unnecessarily you're storing a lot of data, and then it just gets messy. You have to wipe it out every month, or you have to keep tracking it inside a JSON or something, and your whole table starts to look chaotic, right? So this is a good example of relational modeling, where we say let's track any of the monthly usage and everything cleanly, and it's reportable simply from this table, and this just becomes a core sort of a entity that doesn't change so often, right? And then the bit that starts to get very important is qualification request. So as you can see here, why do I need to create a qualification request, right? So user submits a URL and an email to qualify, and if I don't create a qualification request upfront, you cannot point everything towards that single instance or that single ID for which everything is being done for, right? So hence the idea is every user request ends up being a qualification request with a qualification request ID that can nicely tie in to then say, okay, this qualification request ID is for so many provider calls and it has so many keywords and so many page checks. I want to talk perhaps the most confusing and at the same time most interesting design, which is around prospects. Prospect is intentionally not linked to a user, and that's very interesting, because we want a prospect to actually have, let's say I've got a user A and I've got user B. Both of these can want to check the same prospect. Let's say it's dentalclinic.com, right? If they both send that request, if I tie this user request tightly to a prospect, I am actually having to duplicate all of these things. Instead, this design allows us to check individually, is a prospect existing for a specific domain regardless of whoever has requested it, and that allows me to cache or reuse without actually making any of these downstream or extra API calls, right? So a prospect becomes more like a entity which is in a public domain. Anyone can go and look at it. Anyone is just my app that can go and look at it, agnostic of who requested for it, right? And this design helps us do that very nicely. And obviously, as you would expect, a prospect is tied to a qualification request. It is tied to the provider URLs. So you might be it's fairly obvious when you look at keywords and page checks. But you must be wondering, why do I need to store all the provider calls? And this is also an important distinction, especially if you're working with AI products, because you need to have evidence. Anytime you want to look at costs or failures, you need to have a log of when did I hit it, how long did I take, was it successful or not, and how much did it cost. And that's the sole purpose for us to actually track every single call. So every qualification request, as you can see, will have one to many provider calls. I've called it provider so that I keep it loose in the future. If I start adding extra API call to some other source, I don't have to change the name of this table. And then the two tables which are fairly obvious, which are like we are doing page checks to validate is there anything glaringly missing, and the ranked keywords as well. So again, it's a question of, do we want to store this, and what's the value of storing this, and can I not just like do everything in memory within my app and not store this? And this again is a very simple explanation, like we discussed earlier. One, we are linking to the prospects, and we do need this data not just for this user, but we also need to store individual responses so that we know exactly what is coming back, and we can track through every step to make sure that the data is all aligned towards the end. So this is our structure of the 7 tables that we have picked, or the structure that we've frozen. And then I want to flip over and then show you the DDL itself of how that looks like. Fairly simple. You have users, and as you can see, I have taken the decision to not create passwords yet for the free one, because use with just an email ID they're able to query and do a free prospecting. Monthly usage, like we talked about, fairly simple again. Prospects is a core table. As we said, it's a reusable domain table that can be used n number of times, and it should not be linked to the user, right? As The bit that probably is interesting again is a qualification request which is tied to a user, and this is where we create an access token. So every qualification request will have a public token, right? And this token is there for us to set in the user session, which we'll do much later. These are all specific data signals which, looking at the API itself, I have guessed this will change 100%. It will change, but that's okay. It's just a good starting point for me to set this up early on. The provider calls itself, I want to actually store the individual request JSON and the response JSON, and then the cost, the input tokens and the output tokens. So I know exactly what's happening, and as we spoke about the errors as well. Then the ranked keywords, in whatever keywords is passed, sent back to us from data for SEO. This is the exact shape of the data that they send us. As you can see, I have not created a separate table for LLM inference, and I'm actually reusing the same table, so I can keep my models simple and not create another table with more relationships. Page checks as well, it just again linked to a prospect ID, and it tells you what is the status, title and basic information on the page. So yeah, that's literally our database design. One final thing I want to say is I did give this design and some of the API requests, and I asked the LLM to generate, including all of the columns. Very interesting that it added extra columns, and this is what you should be careful about. It added a lot of JSON-Bs that were unnecessarily being stored everywhere. For example, every qualification request was also storing some JSONs, and I'm like, why do I need to store more fields here, right? If I have the core reportable entity per qualification request, I have a provider call that's storing all the incoming input and output of each of the JSONs that we are requesting. We don't really need to duplicate that anywhere, right? So that's one big watch out for. And again, these are all the things that you would miss if you do white code. I hope this was useful, and let's just finish off finally. So there we are, the list of 7 tables that we have created, and now we're ready to get stuck into a very first endpoint for qualification, starting the qualification for the free tier users. Can't wait. See you in the next one.